Queuing theory. Input source. Calling population. One of the characteristics of the input source is its size. The size is the total number of customers. The size may be infinite or finite. Associate with a distribution, usually Poisson distribution or exponential distribution. A customer may be balking who refuses to enter the system and is lost if the queue is too long. Queue. The queue is where customers wait before being served. A queue is characteristics. Queue. The queue is where customers wait before being served. A queue is characterized by the maximum permissible number of customers that it can contain. Queue may be infinite or finite. Queue discipline refers to the order in which members of the queue discipline refers to the order in which members of the queue are selected for the service. First come, first serve is normally used. Service mechanism. It consists of one or more services, facilities, each of which contains one or more parallel service channels called servers. At a given facility, the customer enters one of the parallel service channels and is served by that server. Most elementary models assume one service facility with either one or a finite number of servers. Service time is usually defined by a probability distribution. Real life applications. Railway bookings, library setups and computer systems, hospitals and care centers, banking sectors, toll plazas can be some real life applications.
Now let's discuss about the queuing process rate for various values of arrival rate, that is A. Now for this we have considered A is 20, sorry, excuse me, 20. So this indicates that we get 20 customers per hour. So we fix the average service time by fixing the value of B as in 30. So the average time is 1 by 30. Now let's change the value of A and put 10. Now let's see the output. Now the x-axis is time in hours and the y-axis is queue size. So as we can see, for a value A is equal to 10, we get this graph. Now let's try for another value of A. Let's go to a different, let's close this graphic window, let's go to the SCE file, then we try is 25 now. So let's see what happens. Now there is a change in graph. As the queue size is increasing, the time required does increase. So let's try for a different value of A. Let's see what we can observe from this outcome of this experiment. When we put A as 40, save and execute, we get a different graph. Now what we can understand from this is that because of the randomness of the arrival rate, for this experiment we fix the arrival rate for, like, we are changing the value of A, right? So what we did was we plotted the queue size versus time graph for various arrival rates. So this will be all for queuing theory. Thank you.